Hello viewers, a warm welcome to all of you. In this segment of digital communication, we are going to discuss differential phase shift keying or DPSK. I am Professor Aritro De and this lecture is totally conducted by Ganon powered by Wishback. So, what is a DPSK? It is a differential phase shift keying. It may be noted that an extra bit, symbol 1, has been arbitrarily added as an initial bit. This is essential to determine the encoded sequence. Now let us discuss the algorithm of DPSK. First of all, the binary data taken is 00, 1, 00, 1, 00, 1, 1. Then we have to discuss the differentially encoded data. Here the reference bit is 1. So the differential encoded bit data is 1, 0, 1, 1, 0, 1, 1, 0, 1, 1, 1. In this illustration, it has been assumed that the encoding has been done in such a way that transition in the given binary sequence with respect to the previous encoded bit sequence by a symbol 0 and no transition for the symbol 1. Now, the phase of the DPSK is 0 for bit 1 and pi for the bit 0. Hence, the phase is 0, pi, 0, 0, pi, 0, 0, pi, 0, 0, 0. The shifted differentially encoded data is 1, 0, 1, 1, 0, 1, 1, 0, 1, 1. The phase of the shifted data is therefore 0, pi, 0, 0, pi, 0, 0, pi, 0, 0, 0. Now, the phase is compared. If the phase is same in the sign is positive and phase is different if the sign is negative. The phase comparison output is minus, minus, plus, minus, minus, plus, minus, minus, plus, minus, minus, plus, plus. To detect the data for negative sign minus, the data is 0. And for positive sign, the data is 1. The binary detected data is therefore 0, 0, 1, 0, 0, 1, 0, 0, 1, 1, which is the originally transmitted data. Now you try the same sequence with the reference bit 0. It may be noted that an extra bit, symbol 0, has been arbitrarily added as an initial bit. This is essentially to determine the encoded sequence. You try it yourself and let us check your answer. So what is the algorithm? The binary data is taken here is 0, 0, 1, 0, 0, 1, 0, 0, 1, 1. Therefore, the differentially encoded data is 0, 0, 1, 1, 0, 1, 1, 0, 1, 1, 1. In this illustration, it has been assumed that encoding has been done in such a way that transition in the given binary sequence with respect to previous encoded bit is represented by a symbol 0 and no transition by symbol 1. So what is the phase? The phase of DPSK is 0 for bit 1 and pi for bit 0. Hence, the phase is pi 0, pi pi 0, pi pi 0, pi pi pi. The shifted differentially encoded data is 0, 1, 0, 0, 1, 0, 0, 1, 0, 0. The phase of the shifted data is pi 0, pi pi 0, pi pi 0, pi pi. Now, if the phase is compared, in that case, if the phase is of same sign is positive and phase is different, the sign is negative. The phase comparison output is minus, minus, plus, minus, minus, plus, minus, minus, plus, minus, minus, plus, plus. To detect the data for negative sign, the data is 0. And for positive sign, data is 1. The binary detected sequence is therefore 0, 0, 1, 0, 0, 1, 0, 0, 1, 1. That is the original transmitted data. Very much interesting, isn't it? Okay, let's go. Now it can be seen from the figure that when the bit is low, that is 0, the phase of the signal is not reversed and continue as it was. When the data is high, that is 1, the phase of the signal is reversed. You just draw it yourself. Now let us discuss the modulator of the Dpsk. The serial data input Bk and delayed output data of the encoder Bk-1 is applied to the input of the encoder. The output of the encoder is applied to one of the input of the product modulator. The other input of this product modulator, a sinusoidal carrier of fixed amplitude and frequency AC cos omega ct FCT is applied. Then what is the signal? It is AC cos 2 pi FCT. The output is simply Dpsk data. Now let us discuss receiver or demodulator of the Dpsk. From the figure, it is evident that the balance modulator is given the Dpsk signal along with 1 bit delay input. That signal is made to continue to lower frequencies with the help of LPF. What is an LPF? LPF is simply low pass filter. Then it is passed to a Shepard circuit, which is comparator or a Smith trigger circuit, to recover the original binary data as the output. The output is what? Output is nothing but your original message signal. Now let us discuss benefits or advantage of Dpsk modulation. Dpsk modulation does not require carrier at its receiver circuit. Hence, complex circuits are not needed. And bandwidth requirement of Dpsk is less compared to Bpsk modulation. Obviously, everything has some disadvantage, isn't it? So, what is the disadvantage of this Dpsk? In this case, probability of error or BER or bit error rate is higher in Dpsk compared to Bpsk. The noise interference in Dpsk is more. In Dpsk, modulation uses 2 successive bits for its reception. Hence, error in first bit creates error in the second bit and consecutively error propagates. Now let us discuss the application of Dpsk. The application of differential phase shift keying mainly include wireless communication like radio frequency identification or RFID, WLAN and Bluetooth. The famous application among them is Bluetooth, wherever alternatives of Dpsk has been used like 8-Dpsk and pi/4 DQPSK modulation. Thus, Dpsk is a general type of phase modulation and it is used to transmit data through the carrier wave by changing its phase. This type of PSK removes the need for a consistent reference signal at the end of the receiver, as discussed earlier, by adding 2 fundamental operations at the end of the transmitter. I urge you to practice this segment repeatedly, again and again. Practice with a reference bit 1 and reference bit 0. So, what we have discussed today? We have discussed today Dpsk basic concept, then we discussed Dpsk transmitter, after that we discussed Dpsk receiver, and lastly we discussed Dpsk application. That's all for this segment. Stay safe, stay healthy, stay tuned to Ganon. Thank you viewers. Bye.